So this is another type of problem I want you to know how to do. It's called a molecular formula calculation. It's just like an empirical formula, but you have a little extra piece of information that you got to utilize. So let's say you have 54.54% carbon and 9.10% hydrogen and 36.36% oxygen. And you have this extra piece of information that says the molar mass equals 88 grams per mole. So what I want to first do is do the normal empirical formula calculation, because that technique will always give a formula of a compound in its simplest whole number ratios. So what I do first is, okay, I want to convert everything to grams. 54.54 grams. Assume that I have a 100 gram sample. Convert that to moles. 1 mole of carbon weighs 12 grams. Got that off the periodic table. When I do that calculation, I end up with 4.545, let's say, moles of carbon. Now I want to be real careful and be sure to run those. I'm not worried about sig figs at this point, because I want my calculator to have as many numbers in there as I possibly can to make sure that when I go to figure out what the ratio is, I'm going to have a better chance of getting it. Now I have 9.10 grams of hydrogen. 1 mole of hydrogen has a mass of 1 gram, so that means I get 9.10 moles of hydrogen. Okay, do the same thing with the oxygen. 36.36 grams of oxygen. 1 mole of oxygen is 16 grams, so that's going to give me 2.275 moles of oxygen. Now, what I want to do is I want to take the moles that I've calculated right there and find the simplest whole number ratio of how they relate to each other, because I've gone from looking at this compound in terms of mass to moles. So now I can figure out how many there are. So, like I said the other day, I think the best way is to make a ratio of the largest divided by the smaller. Okay? So, the largest was the moles of hydrogen. So moles of hydrogen, which represented 9.1, divide that by, let's first go with the carbon, moles of carbon, because that was the second largest, so I'm going to divide by 4.545. When I do that on my calculator, I end up with 2 to 1, which looks great. Those are whole numbers. Now I'm going to continue with the largest being hydrogen. I don't want to change anything right now, and I'll show you why in a second. Divide that by the moles of oxygen. 9.1 divided by 2.275 is going to give me a 4 to 1 ratio. Now you'll see that I got a little, it's not really a problem, but I got to be careful right here, because when I figure out the moles of oxygen, with the hydrogen tells me there are 4 moles. When I figured out the moles of carbon to hydrogen, there were 2 moles of hydrogen. There has to be the same number of hydrogen moles in there. So what I'm going to need to do is take the 2 to 1 ratio, okay, and multiply it by some factor to get the moles of hydrogen to be the same. So I'm going to multiply it by 2 over 2. When I do that, I end up with 4 to 2 as my ratio. The important point here is the moles of hydrogen are now the same. Okay? So I can write the empirical formula for this compound to be C2, the 2 coming from right here, okay, 44O1, or like that. All right. So there, I just figured out the empirical formula. That's in the simplest whole number ratio. I write them sort of in order of, the alphabet. Now, go back to that little first part, and I said there was another piece of information. The fact that the whole shebang weighed 88 grams per mole. What do I do here now is I want to figure out what the mass of the empirical formula is. Well, if I have two carbons, so I'm going to move this up, all right, I'll rewrite this. I have C2H4O, and I have this other information, the 88 grams per mole, as the molar mass of this molecule. Well, adding up this molecule, I have two carbons at 12 apiece. I have 4 hydrogens at 1 gram per mole apiece, and I have 1 oxygen at 16. When I add all those up, I end up with a molar mass of 44 grams per mole for this compound. Well, the molecular formula says that it weighs 88 grams per mole. So at this point, I take that 88 grams per mole, I divide it now by the 44 grams per mole from the empirical formula. I find that the answer comes out to be 2. So that means I need to multiply through my empirical formula, C2H4O2 by 2, and I come up with a new formula, C4H8O2. And when I add that up, it will add up to the 88. Reduce it back, I come up with the same empirical formula. So it's a little slight variation, same thing, just adds a little extra ending to it.